Welcome in Core. The James Webb Space Telescope has uncovered a cosmic puzzle. Strange red dots scattered across the distant universe. One of them, known as the cliff, may represent an entirely new kind of object and reshape our understanding of how galaxies and black holes grew in the early universe. In this video, we'll explore three things: the discovery itself, what makes it unusual, and why black hole stars could change our picture of cosmic evolution. The mystery of the little red dots. When the James Webb Space Telescope began its mission in 2022, its powerful infrared instruments allowed astronomers to see deeper into space and further back in time than ever before. Among the galaxies and quasars captured in its early images, researchers noticed something unexpected. Tiny, compact, bright red sources scattered across the distant universe. These quickly earned the nickname little red dots. At first glance, they looked like galaxies, but their properties didn't fit established models. If they were galaxies, they would have contained hundreds of billions of stars squeezed into volumes far denser than anything seen even in the core of the Milky Way. Such structures would have required star formation on a scale the early universe should not have been able to support. Another possibility was that they were quasars, supermassive black holes feeding on surrounding matter. There are commonalities in the distant universe, but these objects didn't match the pattern. Their light spectra lacked the expected high-energy features of dust that obscured them. Instead, they showed unusual signatures that placed them outside familiar categories. This created a scientific puzzle. If they were galaxies, they were impossibly massive and dense for their age. If they were there, they didn't behave like any of those we've studied. The mystery deepened as more of these dots were identified in JWST surveys. Clearly, something new was hiding in the data. To solve the mystery, astronomers turned to spectroscopy, splitting the light of these red dots to uncover what powered them. The Rubies program gathered spectra from thousands of galaxies, and among them emerged a striking case, an object nicknamed the cliff. The cliff and the black hole star hypothesis. The Rubies survey conducted in 2024 collected spectra for more than 4,500 distant galaxies, among them 35 little red dots. One of these stood out immediately. Astronomers nicknamed it the cliff, and its light had traveled 11.9 billion years before reaching us, showing the universe as it was only 1.88 billion years after the Big Bang. Its spectrum displayed an especially striking feature, a Balmer break, a sharp rise in brightness at specific wavelengths. Balmer breaks occur in normal galaxies, typically associated with older stars, but it was far steeper than anything known. Researchers attempted to fit its spectrum with existing models, dusty galaxies, active galactic nuclei, or combinations of both. None matched. It was unlike any galaxy or quasar observed before. This forced astronomers to consider more unconventional explanations. The most promising model was something called a black hole star, abbreviated BH star. Despite the name, this object is not a true star. At its heart lies a supermassive black hole surrounded by a bright accretion disk. What makes it different is the presence of a thick turbulent gas envelope surrounding the system. This envelope acts as both a mask and a filter. High-energy radiation from it is absorbed and remitted, producing a light signature that is compact, red, and marked by the unusual Balmer break seen in the cliff. In other words, the system shines like a star, but its core is a feeding it hidden inside a cocoon of gas. The concept of such objects had been explored theoretically. Some models predicted quasi-stars in the early universe, massive objects enveloped by gas clouds. But until now, there had been no strong observational evidence. The cliff may be the first. Implications for the early universe. If black hole stars are real, they could change how we understand the early universe. Instead of galaxies forming first and then seating black holes at their centers, it may have been the other way around. These may have appeared early, wrapped in gas envelopes, and driven galaxy growth around them. This perspective helps explain one of astronomy's long-standing puzzles: the existence of billion solar mass objects less than a billion years after the Big Bang. Standard models struggle to account for such rapid growth. Its star, continuously fed by its envelope, could accelerate the process, producing the massive black holes we now observe at the centers of galaxies. The discovery also raises new questions. How do these gas envelopes form and remain stable? Do they last millions of years or burn out quickly? How common are they compared to more familiar galaxies and quasars? And how do they transition into the quasars and galaxies we recognize today? The cliff is only one data point, though an extreme one. Other little red dots may turn out to share similar characteristics, or they may represent a diverse population of early universe objects. Follow-up observations are already planned. JWST will take deeper spectra of the cliff and other candidates, while X-ray and radio telescopes may provide additional evidence for the presence of hidden them. Whatever the outcome, the implications are significant. If these stars are confirmed, they would represent a key stage in cosmic evolution, bridging the gap between the earliest stars and the galaxies we see today. They would also remind us that the universe often evolves in ways more complex and surprising than expected. Outro the cliff may be the first evidence of black hole stars, a hidden phase that could explain the universe's rapid early growth. More data will tell if it's unique or part of a vast population. Stay tuned because the universe is always stranger than we imagine. Subscribe for more discoveries. Thanks for watching. Cool.